guys, let's take a look at example 3 in topic 7.2, angles in the unit circle. We are going to start getting into using the unit circle, what it is. This is very fundamental to trigonometry. This portion here really doesn't have a lot for you to do. I'm going to explain it to you. This is really a one-time deal. Once you kind of understand this, you're just going to apply it to the unit circle and we're going to start running with it. So some key ideas that we need to remember. Unit circle means we have a radius of 1. So that means this distance here from the origin to the outside of the circle, right on the circle here, that's a measurement of 1, which means if you go over to the left, your x value is a -1. Notice your y, if you're on the x-axis, it has a value of 0. Here we are up here at 90 degrees. Your x value is 0, your y value is 1. Down here at 270 degrees, again, your x value is 0, your y value now is -1. This distance all the way around is 1. So we're going to start using common angles, those reference angles that I kept referring to, 60 degrees, 45 degrees, and 30 degrees. Those are going to be important angles for you to remember, and their coordinates on the unit circle. And we can calculate their coordinates by using that right triangle trig that we've been using since topic 7.1. Important also to remember that you should have seen in your lesson, cosine is your x, sine is your y. Think about it this way, alphabetical order. X, y, alphabetical order. Cosine, sine, alphabetical order. So here we are on a 60-degree triangle. Remember, that's a special triangle. And you guys actually calculated a lot of these, maybe with a different hypotenuse, but you still got the same answers. Back in 7.1, I believe it was in your try at number 4 and 5, if you want to go back to those and compare them. So here we are, hypotenuse is 1, here's my adjacent. That means cosine of 60 degrees, the value of x is 1/2, which remember that's that adjacent leg. Well, if you can relate that back to a coordinate plane, your distance from the origin is your x value. So this x value is 1/2. And then my height, your sine of 60 degrees, is going to be your opposite, which we calculated it out to be square root 3/2 over the hypotenuse, which is 1, which gives me a value of square root 3/2. Sine, of course, opposite of your theta, relates to the height, which is also y. So that means my coordinate, when my theta is 60 degrees, my x value is 1/2 and my y value is square root 3/2. 45 degrees, that was actually your try it. Here it is. Again, another special triangle, 45, 45, 90-degree triangle. We use the ratios, calculated cosine of 45 degrees to be square root 2/2, and sine of 45 degrees is also square root 2/2, because if you remember in that special relationship, your legs are equivalent. And so here it is. The coordinate when theta is 45 degrees, x is square root 2/2, y is square root 2/2, and then again, 30 degrees, here it is, did the work. You guys have already done this. This is posted in focus in your notes if you want to review it. This is the derivation for a lot of what we're going to be working with. Just keep that in mind. You will not on a test have to do this. I'm going to be showing you the unit circle and some easy ways to remember your coordinates. But go ahead, review this. It does help if you understand the concept behind what we are doing.